All right, very last part of the review, transformations. Let's see, where am I? There we are. Okay, so we are doing transformations to this function, which is a bunch of line segments, 4 to be exact. And number 47, I see two transformations. I see the x plus 1 in parentheses, and I see the plus 2 on the outside. Both of those are shifts. The plus 2 is going to shift the graph up 2. The x plus 1 is going to shift the graph to the left 1. Remember, anything with an x does the opposite of what it appears to do. So instead of going right 1, we will go left 1. And I'm going to focus on the 4 main ordered pairs. I guess 5. We'll include that one over there. And so we have the ordered pairs -3, 2, -1, 1, 1, -3, 2, 1, and 4, 1. I'm just going to take each one of those, go left 1 and up 2. So I was at -3, 2. I'm going to go left 1 up 2. -1, 1, then left 1 up 2. 1, -3, then left 1 up 2. 2, 1, so 2, 1, then left 1 up 2, and then here. And then we'll just maintain the shape of the graph, which this one's pretty easy because it's all linear. And it's going to look like this. So there is your graph for number 47. There we go. Let's see, so 48. And what I did on the rest of them is I just went ahead and copied the graph onto all of them. Makes it a little bit easier. So 48. Oh, geez. That's not what I wanted to do. Here we go. Ah, come on. I'm trying to grab. Oh, now I see what my problem is. Well, shoot. Okay. I'll just leave it as is. Okay, so 48, I see two transformations. I see the -2 and the -1. And what those two transformations are for 48, the -2 will multiply the y's because it is not inside with the x, so it's going to affect the y's. We're going to multiply the y by -2. And then the -1 is going to shift the graph down 1. Now, if there's multiplication in the problem, let's separate the two problems here. If there's multiplication in the problem, what you could do is write down all of the ordered pairs for your original function f of x. And so we had the ordered pairs -3, 2, -1, 1, 1, -3, 2, 1, and 4, 1. And then the transformation is telling you to multiply the y's by -2. So we're going to keep the y's the same, or the x's the same, and multiply the y's by -2. So all of these ordered pairs, the x's won't change, so it's going to remain -3, -1, 1, 2, and 4. So those aren't going to change. Forgot to write 1, down 1. But I will multiply the y's by -2. So 2 times -2 is -4. 1 times -2 is -2. -3 times -2 is 6. 1 times -2, and 1 times -2. And then we could graph those 5 points. Now remember, that's only taking care of the stretch factor, the multiplying the y by -2. So I'll have -3, -4, -1, -2, 1, 6, which is going to be way up here somewhere, 2, -2, and then 4, -2. And then I need to take each one of those. That took care of the multiplying the y's. Now I need to take each one of those and move them down 1. So I'll just take these and go down 1. Down 1. This one up here, down 1. Down 1. Oh, got both of them. That was convenient. And then we'll connect those with line segments. There. There. And there. So there's 48. 49, again, I see two transformations. I see the 2 and I see the +4. So I see two transformations. The tricky thing with this one is it appears, I'm going to try and decide where I'm going to move this down here. It appears that there is a shift to the left 4 units. Now there is a 2 times an x, and that is inside with the x, so that's going to affect the x coordinates, and we'll do the opposite of what it appears. So we're actually going to divide the x's by 2. We're going to divide the x's by 2. But that plus 4 is not a shift left 4. It's actually going to be a shift left 2. And that's because anytime you're determining a horizontal shift, you want to make sure that inside the parentheses you have a coefficient of 1 with your x. I would rather have a 1x instead of a 2x. So what I'm going to do, that 2x plus 4, I can factor a 2 out of that. And if I factor out a 2, that would leave me with an x plus 2. So 2 times the quantity x plus 2 is the same thing as 2x plus 4, but that 2, we're not factoring it out of the function. We're not taking it all the way out of the f. It's going to stay inside the f like this. So it's still 2 times x. We're still going to divide the x's by 2, but we're actually going to shift left 2 units instead of left 4 units as it originally appeared. Always do your shifts at the end. If there's any multiplication or division, you should always do your shifts at the end. So I'm going to start by dividing my x coordinates by 2. And so I'm going to grab this same list of x's right here. Actually, I don't need that. I need this. So I'm going to grab that list of x's, move you over here, and then we're going to divide the x's by 2. So we're going to have x divided by 2, and we'll keep the y's the same. So all the y's will stay the same. So all the y's stayed the same, and then we will divide the x's by 2. So negative 3 divided by 2 is negative 3 halves, same as negative 1.5. Negative 1 divided by 2, negative 0.5. 1 divided by 2, positive 0.5. 2 divided by 2 is 1, and 4 divided by 2 is 2. And then just like the last one, I could graph those. So negative 1.5, 2. But then we're supposed to shift left 2 units. So I'm going to take that point and go left 2 units, and we'll actually end up right here. So let me get rid of that. It's going to end up there. Negative 0.51, so negative 1/2, 1, left 2. Positive 0.5, negative 3, left 2. 1, 1, left 2. And then 2, 1, left 2. So there are the 5 key points. We'll connect those with the line segments, and here's our finished graph for number 49. There we go. Move that up some. All right, so there's 49. And then the last one, number 50, we have an absolute value of the whole thing, and on the inside we have the plus 1. I've been saying pretty much the whole unit that if there is a shift left or right, you want to hold on and do that at the very end. I need to adjust that statement. You do it at the very end of all of the multiplying or dividing. So like on this one, when I had to divide the x by 2, I have to do that before I shift. When I multiplied the y by negative 2 on 48, I have to do that before I do the shift. In this case, absolute value, the order is a little bit different. By the way, this one is written, and that's because the plus 1 is part of the absolute value. I'm going to actually ignore the absolute value for now, and I'm going to graph f of x plus 1, which is simply a shift up 1. So I'm going to go up 1. I'm going to take all of these points and shift them up 1, up 1, up 1, up 1, up 1. Okay, and this is what the graph is going to look like after that initial shift. I'm going to do it in dots because I'm not done. Oh geez, that's not what I wanted. There we go. So there is shifting my graph up 1 unit. Then when we look at the rest of it, we remember, oh, but that graph, we have to take the absolute value of that shifted up graph, and the absolute value of the whole thing is going to take any negative part of the graph and flip it positive. That means anything positive will remain exactly where it is. So I'm going to just trace over the parts of this graph that are above the x-axis. Everything above the x-axis, which I'm above, right there, I quit. So everything from the x-axis above will remain exactly where it is. And the absolute values are going to reflect up over the x-axis. So what that absolute value is going to do is we're going to reflect all negative y's, all y's less than 0, over x-axis. Okay, so here I have a negative y coordinate. That ordered pair is 1, -2, and the absolute value of -2 is +2. So that point's going to flip up here. And there are some other points. Now, they're not clearly defined, but like right here, I have a point of 1/2 -1. So that point's going to reflect up to 1/2 +1. Right here, this looks about like 1/4 -1. That's going to flip up to +1. And when I reflect this little triangle little thing above the x-axis, it's going to end up looking like this, starting here, up to there, and then back down. And then that graph looks kind of like a W now. That is going to be the final graph. So we started by shifting up 1 because that was inside the absolute values, had to do that first. Then after that, whatever negative parts of the graph existed had to be reflected above the x-axis to become positive, and that is all of it. So there is your review.